Hi guys, I hope you're doing well. What I want to go over with you today is Unit 3, Homework 4. So I'm going to go through part of the stuff that's in Lesson 3 for you. One of the things you will find is the Loan and Savings Formula Quick Sheet. So whether you're trying to save money with one lump sum and you're going to let it sit there for a while, or you're going to take out a mortgage, there are three formulas that will allow you to do this without having to go to Excel so you can decide, make plans for your future. One is the compound interest formula. That's the very first one on the quick sheet, and it has a couple of variables listed with it. A is your accrued or accumulated value. It's the value at the end of your savings. The P is the principal. It's the principal amount of money that you're going to invest, your initial amount, or it could be the amount of money you're borrowing. So principal is that huge lump sum. The R, the lowercase r, is for the annual percentage rate, and it must always be in its decimal format in order to use. N is the number of times of year that interest is going to be compounded or added. The most common value for N is 12. Your credit card bills, they bill you monthly. Your mortgage payments are done monthly. So N is the number of times that interest is either earned or charged to you. And for the most part, N is monthly. It could be quarterly, which would be 4 times a year. But for the most part, for most of ours, it'll be 12. And T is always time in years. That can be a little tricky because if you decide to deposit money in only for 9 months, the T would be 3/4 of a year or 0.75. So just remember T must be time in years. So if it's a lump sum, you use this top formula. You're always going to be allowed a reference sheet. If it's an annuity account, like the 401, 403Bs, that's when you're adding money every single month. So you're getting interest on the amount of money that's in the account, but you're also making interest on your interest. And then you're adding a monthly amount. So each month, it's the amount in the account plus the interest on the previous amount plus the new monthly amount that you added. So this kind of an account will grow much faster than a simple lump sum account. So the formula is a little bit different where the D stands for the deposited amount, but everything else is the same. The A for accrued value or accumulated value. D is your regular deposits, normally monthly, could be quarterly. Um, R is your interest rate, always in its decimal form, N, the number of times of year, and T is time in years. And then the last one is if you're going to do a car loan or a house mortgage. That's your loan formula. And it's similar to the previous one. Look at the two formulas. P equals, now it's your principal amount, the amount you start off with is D, and then the top is 1 minus 1 plus R over N, close parentheses, raised to the negative N times T, and all of that goes over your rate divided by the number of times. So these two formulas are quite similar. So just take a look at what you have. I like to identify all of my variables first so that I know what formula I am using. So if I go to this practice worksheet, this practice worksheet is in Lumen for you. I've highlighted the key parts already to try to keep the video a little shorter. And down the side, I like to identify my variables. So I'm going to insert a small text box right on the corner here to identify my variables. Going to lower this down, and then in this text box, I'm going to put, oops, I got to lower it a little bit more, so I'm underneath the other one. A little lower. And I'm not sure why it's not going down now, but there it is. Okay, so in this box, I'm going to start with P equals, because the very first word I see is the word investment. So I know that the investment is $6,000. The very next thing I come across is the interest rate, 5.4%. So R equals 0.054, so that it is in that same format that we need. And I keep reading, compounded monthly, that's the N. The N is 12 times for the year, and the T in this case is going to equal 15 years. So T is always time in years. And now I'm just going to move this out of the way so it's on the side. So I have P, R, N, and T. And the question is saying, how much will I have in the account if the bank compounds monthly and I leave it in the account for 15 years? So at the bottom, and I'm going to go in italic size so that you could tell it's different, I'm going to just tell myself, what am I answering? So I will have some amount of money, I don't know what it is, in the account at the end of 15 years. So this is what I am trying to figure out. So what formula would be the best formula to use? I'm looking to accrue some type of money. So I go back here and I look at what we have. Compound interest. This is most likely my best formula to use. So I'm just going to go to the snipping tool and bring it over quickly. I didn't open it earlier, so I'm going to hit new and just grab the formula. Whoops, I grabbed too high. So you know which formula I'm using. I am going to use this formula. So I'm going to go back to the worksheet, and now I know this is the formula that I need to use. So over to the right of it, A equals, well, what's my principal? It's 6,000, 1, 2, 3, and that's going to be times 1 plus, I need my interest rate divided by my number of times. So if I'm typing it up this way, I need the fraction. I need my interest rate 0.054 divided by 12. And all of this is going to be raised to the exponent of n times t. So I'm going to just grab the exponent and make sure that this looks like that. So the parentheses, the n here is 12 times, I'm going to use the little asterisk just so that you know what it is, 15. And now I have to figure out, how am I going to put this into a calculator? Everything's set up, and I need to be able to put this in a calculator. And the one thing I did not do was open up the Desmos calculator for you. So I will do that now. I need to go to the Desmos calculator. It would have helped if I opened it ahead of time. So I just need to go get a new tab. And I'm going to look for the scientific calculator because this is the one we use. Now, I don't know if you remember everything that was in there, but the first thing that was in, I'm going to move this up a little. The principal was $6,000. So it was $6,000, and that is being multiplied by, and I can use the keys here, 1 plus 0.054 divide by 12. And what's nice with this Desmos calculator is it'll already turn it into the fraction for you. And I need to go outside and tell it to put the parentheses in. Now I need my exponent. So I could, hit too much. Hit the exponent key, and I wanted to put all of the 12 times 15, so I need another set of parentheses, 12 times 15, and then I have to close off the parentheses, and you will see on the right-hand side, you're going to get 13.629. It does say in the directions to make sure to take a screenshot of this. So I'm going to go get a new screenshot, hit new, and I want to grab everything in the calculator to show this as my work. Go back to where the work is due, and right underneath here, hit Control V. So I'm going to shrink this a little so that I can get it on the side. Didn't mean to do that. That's a little too small of this. I'm going to bring my sentence up because now I can answer the sentence. So I'm going to bring it back. And now I just have to fill in the amount. I can see the amount right here on the calculator. The amount on the calculator is, now I have to make sure that it looks like money. So I have the dollar sign, 13,462 point, and I think this says 96. So I have now identified the variable, identified the formula, shown my work, and I have answered the question that was asked. And I could highlight this, or I could change the print to a different color to make it easier to see. Let's try this again with the second one. I don't want to retype the whole box over, so I'm just going to hit copy, bring the box down here, Control V, paste, and I'm going to see what is in this question. The only thing I'm going to do now is raise it up a little and empty out the variables. Well, I may not have to empty them all out, so maybe I should read first before I empty these all out. Number 2 says, suppose I want to invest as an investment money into an account that offers 6.2% annual interest compounded monthly. So 6.2%, I could fill in 0.062 compounded monthly is going to stay at 12. I want to leave the money in the account for 25 years. So my time is now going to be 25 years. And I want to have a total of $50,000 at the end of the 25 years. how much should I invest today? So I'm looking for a total at the end of the 25,000 years. Let me go back and look over here. Okay, so I guess the best one is I'm looking for interest. So again, I'm going to take a new screenshot. This is the formula I need, except I have different parts of the formula this time. Let's show you what I mean. Control V, I'm going to shrink it a little, and I'm going to fill in the parts I have. But before I do that, I want to know how much I should invest today. So I have to start with my question. So I'm just going to take the question from here, put it down here. I need to invest, I don't know how much, in order to have $500,000 by the end of 25 years. So this is the question I ultimately need to answer. So in the meantime, what I'm going to do is I do not know what the P is, but I do now know what the A is. My end goal, the amount I want at the end, is 500,000. So as long as I identify what I have and where I want to go, it will make it easier for choosing this formula. But there is a little bit something different with this. This time I know the A. I know the A is $500,000. And I want it to equal, I have to figure out how much money to put in. I do not know how much to start with. But what I do know is the 1 plus my interest rate 0.0, whoops, let me put it in a fraction, 0.062 divide by 12. I'm just looking to the left to get what needs to go in here. And I need to raise this to an exponent. So I'm going to go back to this section and just grab this one. Close my parentheses off. And the exponent is going to be 12 times 25 this time. So this is a little bit different in that I have stuff on both sides of the equal sign. So how am I going to do this? Well, the first part I need to figure out is what all of this part equals. All of this, I need to figure out what this equals. And once I know what this equals, I can divide both sides by this amount. Hopefully that will make some sense to you. So let me go to the Desmos calculator. And I'm going to try to keep part of this. I wrote some of it out on a piece of paper so that I wouldn't forget what I had to put in the calculator. So I'm going to go to the Desmos calculator. I'm going to clear everything out. I could do this in one step, or I can do this in multiple steps. I do know that I want to end with the $500,000, and the $500,000 needs to be divided by everything that is on the right side currently. So I do know that the 500, if I get to 500,000, this whole $500,000 needs to be divided by, and I'm going to put a lot of stuff in here. It needs to be divided by, and in order for this to know that I want it to take everything, let me just show you what I wanted to take. I wanted to do all of this, all of these pieces here, so that I'm dividing this side by this to get the principal by itself. Hopefully that makes some sense to you. So I'm going to go back to the calculator. So what is on the other side? I haven't opened parentheses, but I'm going to open a second. Whoops, get back. I waited too long, so I came out of it. I'm going to open a second set of parentheses and put 1 plus the interest rate was 6.2%, so 0.062 divide by 12. See how nice it does that for us? And then when I close out this parentheses here, I can now go to the exponent that I wanted to do. And again, the exponent has to be in its own set of parentheses, and it was 12 times 25, and then I got to close the little parentheses. Whoops, that's not the little parentheses. Close the little parentheses, close the big parentheses. So I don't know if you can realize that this is now going to equal the value of P. So what this is saying is that I have to put $106,548.31 into the account initially. Okay, let me grab a screenshot of this and move this over. I'm going to take a new screenshot of everything here and move it over into my work shown. So for my work shown, I'm going to hit Control V. I will shrink it just a little bit so I can put it on the side here and take up a little less space. So, maybe I should have left it a little bigger so you guys can see it. Well, it's taking up a lot of space. So that number, hopefully you can still see it, says 106,548.31. So to answer question 2, I've identified my variables, I picked the correct formula, I filled in the formula, I solved it in the Desmos calculator, and I answered the question. Okay, going down to number 3. Let's see what number 3 says. Just going to back that out a little. Okay, so number 3. I need to put a little bit of space in here. And on number 3, I need to identify some variables. So I'm going to take the one I had before, hit Control C, down to Control, whoops, guess I didn't save it. Okay, I would like to steal this. So I'm going to copy it because I don't want to retype it. That's the only reason why. Control V. And move it up a little to see what I have here. And let's see. I want to invest $800 per month into an account that offers 5.4%. Well, I can get the 5.4 switched over quickly. 0.54 for 30 years. So I'm going to change the time to 30 years. I'm going to back out of the 500,000. And I know that the monthly payment, so my monthly deposit, this is now going to be a D. And they're telling me to put in 800. So I'm just identifying the variables that we have. Okay, let me go back to show you where I got all of this. I want to invest $800 per month into an account that offers 5.4% annual interest rate for 30 years. How much will I have in the account at the end of 30 years of savings? So the 800 per month is a deposit for each month. That means it's going to be an annuity account. 5.4% in decimal form. Month is 12. Time is 30 years. And I'm looking for that accrued amount after 30 years. So I need to find the formula that has all of these pieces in it. So I'm going to go back to the formula sheet, find the one that has those variables, which is the annuity formula. And I'm just going to screenshot it rather than type it. I could just type it again. It would be probably just as easy. But I'm just going to screenshot, bring it over, bring it to the top here, Control V. This is the formula that I now have to figure out how am I going to fill this in. So there's a lot of pieces to this formula. So I don't know the A. The A is what I'm looking for. So A, I'm going to see if I can get this to go a little bit higher. Nope, I guess not. Okay. So A equals, well, I have a lot of stuff going on here. And there's a fraction bar. So I'm going to insert my fraction. And the bottom of the fraction is probably easier to fill in than the bottom. So within the bottom, I need another fraction. So in the bottom, my rate is 0.054. The number of times is 12. So the bottom of the formula is filled in. I have to fill in the top part of the formula. The D is going to be $800 a month, and that is going to be multiple. So we have to have two sets of parentheses, basically, or a bracket and a parentheses. So you see that? A bracket and a parentheses. 1 plus, I need another fraction, the interest rate. The interest rate is going to be the 0.054 divide by the 12. And all of this is going to get raised to a power. I don't want to get all the way out to the end. I just want to get to this little, whoops. Okay, get to the 12. Okay, and now I'm going to do this so I can put that second set of parentheses in right here. And this is going to get raised to the n times t. Well, n is 12 times t is 30. And then from all of this, I just need to hit a little spot to get out, minus the number 1 and close the bracket off. So this is what it looks like. That's a lot of stuff. Can we get all of this into the Desmos calculator? So I, again, wrote it out on a piece of paper so that I would be able to see what I have to put into the calculator. So I want to get all of this into the calculator at one time. Okay, so I've written it out on a piece of paper. Make sure it looks like that. Yes. Okay, I'm going to go back to that Desmos calculator. I'm going to clear out everything that's in here. And I need a fraction to start all of this because there's a lot of stuff on top and on bottom. So the top part of the fraction is the 800. And using the parentheses, I still have to use a double set of parentheses here because it's not a bracket. And then I'm going to start with the 1 plus, that's not a plus, I'm so sorry, plus, there it is. And as soon as I put in 0.054 and hit divide by, it's going to make the fraction for me. Divide by 12, and then all of this whole thing is going to get raised to that exponent. Now I need to tell it to do the 12 times 3 in the exponent. So, 12 times 30. 12 times 30, 30. Close off that parentheses. Close off this big parentheses. Now on the bottom, I still have all the stuff in the bottom to put in. So it's going to be, and I need to tell the bottom to do all of this, 0.054 divide by, it will put it in 12, and then just close off the total parentheses. Whew, that was a lot of work to get to here. Now, I just want to make sure it looks correct. So it's the $800 a month times, oh, I left something out, the -1. -1. So what's nice with this is I can go back in. I was just verifying this to what I wrote on my paper. So you might have caught it before I did. So now when I put that in, it looks like we're going to have $717,290.70. I wanted to make sure I said that out loud once before I take the screenshot. Okay, I'm going for the screenshot. New. Capture all of this. Go back to where I'm going to show my work and hit Control V. So I just may leave this one down here only because it has a lot more and make it easier to see. And I don't want to retype the sentence. So I'm just going to take the sentence from here. Whoops, I don't know what I just did. Bring this back up to 100%. Whoops, I lost it. Control C, I'm trying to copy. Control C, go down to the current question, hit Control V. And now I can add in, I will have 717, comma, 290.70 in the account at the end of 30 years. I guess I should put years on that top one. If that's saying years, that means the first one is missing the S too. Years. So when you're doing your work, you want to work smarter, not harder. So this is all of 3. This is what I will be looking for when I grade your unit 3, number 4 homework. You need to use the equation. Now, if you are doing this in a calculator, like a graphing calculator, you're going to have to show step by step. That's why I like the Desmos calculator, because I can put all the pieces in at one time and be done with it. Now, question 4 has multiple parts to it. Question 4 says, I want to retire. When I retire, I want to have enough money in the account so I can draw $1,500 per month for at least 30 years. So The first part of the question says, how much do I need to have? Well, I want to be able to take out $1,500 every month for 30 years. So how much do I really need at the end of that savings account is basically what it's saying. It's saying, how much do I need? So I need to have the 1,500 times 30 years to know how much I have. And I could do the same thing. I can just go back to the Desmos calculator. I'm going to clear out everything that's in here. I'm looking for $1,500 a month, every month for 30 years. And this is a way to know like that I'm going to be safe and have enough money in there at the end to retire with. So I think I'm missing a zero here. Let me go back and read the question. I want to be able to take $1,500 per month for, so here's where my mistake is. It was $1,500 per month for 30 years, but 30 years has 12 months. So that's much better. Let me go back. So I have to then multiply this, because it's per month, by the 12 months. For this 12 months, I could have just did 1,500 times 360. Okay, so let's see what we get on the calculator. The calculator says it's going to be $540,000. Now, this is relatively easy. So I could just go back and say, well, I need to have a minimum of $540,000. So I will need to have saved, this is a little bit different wording than the other, $540,000 before retirement. And if I want to make it look like the others, I could just do it in purple and italicized so it shows. Okay, hopefully that will make some sense to you. So now it's saying, I want to retire in 20 years. And I want a plan that will give me 5.1% interest. How much will I need to put into the savings account each month in order to retire? So I know my end balance, my accrued balance, the balance I need at the end has to be $540. And I'm going to add each month. So this is starting to sound like an annuity account to me. It's definitely sounding like an annuity account to me. I'm not going to have enough space on this page, so I'm going to lower it to the next page so we can get all the work on one page. And I'm going to move some of this other stuff out of the way. All right. So this is sounding like an annuity account. I'm going to come back here. I have an ending balance in mind, and I need to know how much I need to put into the account each month. So it's very similar to what we did up here, except this time we know the beginning balance. We know the beginning balance this time. So let's go back and find the annuity formula. This is the annuity formula. So I'm going to take a screenshot of the formula that I need, hit new. This is what I am looking for. I'm looking for this. So I am going to add this in up here. Now, I also need to identify the variables. So before I do that, let me grab something that I can identify the variables with. And I'm just being lazy by hitting copy and paste. And I want this to actually be in front of this one. So Control V, and I want to move this up. And what I don't know this time is I'm looking for how much has to go in each month. I do have a goal in mind. The goal in mind is to have $540,000 at the end. It's monthly, so it's 12. We only have a 5.1% interest rate. So I'm going to change that, and I plan on retiring in 20 years. So now I'm going to look at everything we have here for Part B. I have everything set up. I just have to type up how I'm going to type this into the calculator. So the first thing I'm going to do is set up what I already know. I know that I'm looking for $540,000. And that has to equal, well, let me get one of those fraction bars again. It's a lot of thinking when doing these. It really is. It'll probably be easier for me to do the bottom on this. I'm going to do the bottom first. And the interest rate is 0.051. N number of times is 12. So I was able to do that quite easily. And the top here is, I don't know. I'm trying to figure out what that monthly deposit has to be. So I'm going to do the same thing, set up a bracket and a parentheses. Let's move this off so you can see what I'm putting in. 1 plus, and now I need a fraction inside my fraction again. And the top is my interest rate, 0.051. The bottom is the number of times, which is still 12. I got to get outside of this, and I'm going to need an exponent. So I need to go on the, stay on the top. Whoops. There it is on the top. And I'm going to need to close off the parentheses. And my exponent is going to be n times t. So it's going to be 12 times 20 years. And then outside of this, I'm going to subtract 1. Okay, so there is everything all set up. And again, I have written this on a piece of paper so that when I go over to the Desmos calculator, I know exactly what I will be putting in the calculator. Well, at least I thought I did. 0.51. Okay, here it is. I did write it on a piece of paper. So now let's think about this. When I'm ready to put this in the Desmos calculator, I want this D by itself. There's a lot of work. So I guess the first thing would be if I multiply both sides by this amount on the bottom. If I multiply this by this, and then divide by what's left over. So I'm going to write one more step here so you can see what I'm going to do so I can get it in the Desmos calculator. So what I'm looking to do is to take the 540,000, and if I multiply by what's on the bottom, this here part, it'll come off of both sides. So I just want to make sure that we all see the same thing. So if I multiply by what's on the bottom, 0.051 divide by 12, which remaining on the other side will be the D times 1 plus, now I'm going to add the fraction in again, just trying to keep it straight in my head so that when I go to put this in the calculator, I know what I'm putting in. 0.051 divide by 12, and all of this is going to be raised to an exponent. So I'm going to close off the parentheses, and the exponent is going to be 12 times 20, 20. And then from that, I'm going to hit minus 1. Okay, so this might make it a little easier so I know what I'm putting in the calculator. So, it's a lot here. So what's going in the calculator is all of this divided by all of this to get the D by itself. I want to get the D by itself. So I need to put everything on the left side and divide that by everything on the right side. So I'm going to go to the Desmos calculator now and try to remember all of this. I'm going to hit clear. And I did write it all out so that I would remember. So everything on the left side is going to be divided by everything on the right. So I'm going to start with that fraction again. So everything on the left is the 540, 540,000, and that's going to be multiplied by the little fraction that was on the bottom, 0.051 divide by 12. So all of that now becomes my numerator. And I'm dividing that by everything that was on the right side of the equal sign. So everything that was still remaining on the right side of the equal sign is the 1 plus 0.051 divide by 12, and that was raised to an exponent. So this gets raised to an, whoops, I do not want to do that. Undo. I need another set of parentheses inside. So I want to raise that to an exponent of, okay, I believe I need another set of parentheses, which means I need one on this side too. Okay, so I'm going to raise this, and there's my exponent. 12 months, 20 years. 12 months times 20. And the reason why that happened is I did not use another set of parentheses. So there's a lot of set of parentheses to keep in mind here. Okay, and then the last thing from this would be to minus the 1 and close everything off. So it looks like we have to come up with $1,298.66 each month to have enough money for the 20 years. Let's take a screenshot of this so you can see what this looks like. I'm going to take a screenshot. I'm going to add it right into my document underneath. So here's all my work, and now I have to answer that question. How much do I need to save? Let's see. I'm just going to reuse this sentence to make it work for this situation. Okay, I will have to save, if I can read that number again, 1,298,298.66 each month in order to have $540,000 in the account at the end of 20 years. And now I'm ready to retire. And after that one, I hope you have enough examples here that you can go back and do this on yourself, by yourself. So this is what I will be looking for when you do your own work. And I hope to see you later. Take care. Bye.